What's up, guys? Hope you're doing well. I got something to show you. So you guys have heard of Sasquatch and the Yeti, but have you heard of the like monster? Alright guys, today we're looking at 12-7A. We're going to be skipping 12-6 and going right to 12-7, solving nonlinear systems. Today we're going to be looking at how to solve these nonlinear systems using substitution and elimination. Monday we'll be looking at how to solve these using our graphing techniques. But today just focus on substitution and elimination. Now you guys have done this before in Algebra 1 where you use substitution and elimination to solve. So it's going to be very similar to that. Same concept. We're just going to be looking at our nonlinear systems. So what is a nonlinear system of equations? Well, a nonlinear system of equations is a system in which at least one of the equations is not linear. So you can have one of these two equations, because we're going to have these two equations that we're looking at. One can be a line, but the other one has to be nonlinear, not a line. Both could be nonlinear. That's okay. But at least one cannot be a line. So we've been studying one class of nonlinear equations, which are the conic sections. So we have those four conic sections we've been looking at. We're going to be mixing all of those and basically just looking for points of intersections. So our solution set is a system of equations, and it just acts like, or it is the set of points that make all the equations in the system true, or where the graphs intersect. So all we're going to be doing is just looking for points of intersection. For the systems of nonlinear equations, we must be aware of the number of possible solutions. So when we look at our two graphs, we'll see that there could be multiple points of intersection, there could be no points of intersections, or there could be one. So we look at this one right here. We see that there are no solutions because on both of these graphs, they never touch each other. There's no points of intersection. So since there's no points of intersections, we're going to have no solution. We look at this one, the graph, we have a circle, we have our parabola here. We see that they touch each other at exactly 1 point. So that would be one solution. Since they intersect at 1 point, we have one solution. Now, here we have a circle. We have a line going through the circle. So since we have the circle and the line going through it, we have 2 points of intersection. So we'd have two solutions. On our third option here, or fourth option here, sorry, we have a, let's see, looks like an ellipse. We have a parabola, and we have 1, 2, 3 points of intersection, so we'd have 3 solutions. Our last one here, we have 4 solutions because we have our hyperbola, and we have our ellipse. And if you see the points of intersection, you'll see 1, 2, 3, and 4 points of intersection, so we'd have 4 solutions. So that's the picture that we're looking at. That's the general idea. We can use a graphing calculator to find these solutions, but we're going to be looking at how to do this all by hand. Now, quick note, if we're on a coordinate plane and if we're graphing everything and we're looking at the intersection points, we're going to have XY coordinates as our solutions. So you will be getting an actual coordinate as your solution. Alright, so let's look at how we can solve for our system of solutions using substitution. So the first thing we're going to do, here is the system of equations. Notice that we have two. We're going to be looking at, if I were to graph these, we get are two shapes, and we're going to be looking at where do these shapes intersect each other. Notice that we have a circle here and parabola here. So it'd be something like, I'm just going to see, this would be a vertical one. So it'd be something kind of like, something like that. I'm not sure, but it'd be something like that. So we're going to be looking for, maybe we have two solutions, maybe we only have one solution, maybe it's upside down, like this. We're just going to be looking for these points of intersection, wherever they may be. Alright, let me erase this, and then we'll start solving this. So using substitution, we're first going to try to look at what we have in common. So notice here, we have an x squared, and we have an x squared right here. So what I could do, I could take this part right here, and since it's equal to negative x squared, if I solve for x squared, I can substitute it directly in for this x squared. I could also work the opposite way from here using that equation. There's different ways I could solve this, but I'm just going to show you guys one way here. So what we're going to do, I'm going to take this equation. I'm just going to solve for x squared. So x squared is going to be equal to, I'm going to multiply this up by negative. What I do to one side, I do to the other. So this will give me negative y minus 5, which x squared is equal to negative y plus 5. So that's what I'm going to be working with. So now what we're going to do, we're going to take this equation here, we're going to substitute this part in for this x squared right there. Since x squared is equal to negative y plus 5, I can take the negative y plus 5, directly substitute it into this x squared. This will give me, when I substitute, come over here, this will give me negative y plus 5 plus y squared equals 25. So this equation goes right there. I take the negative y after solving for x squared, negative y plus 5, substitute in for the x squared, and that will give me this. And now it's just a typical polynomial that I need to solve for. Let's solve for y. So let's rearrange this. I get y squared minus y plus 5 equals 25. I'm going to subtract the 25 over. Set equal to 0. Get y squared minus y minus 20 equals 0. Now I can factor this using a's and b's. So I get y minus 5, y plus 4 equals 0. So y is equal to 5, and y equals negative 4. Now I'm not done, because all I've done, remember I have to have an xy coordinate. All I've done is just solve for the y part. Notice that I have two y solutions, which is totally fine, because all this means is that I'm going to have multiple points of intersection. So since I've solved for y, I'm going to have two options here. Let's first start by solving for when y equals 5. So all I'm going to do is take y equals 5 and plug it to either of these equations. Doesn't matter, you just pick. I want to use this one here. So if I plug in 5, I get 5 minus 5 equals negative x squared. 0 is equal to negative x squared, so x squared equals 0, so x equals 0. So what happens is that my first coordinates, make sure it's xy, I have an x coordinate of 0 right here. And then since I was using y equals 5, I get 0, 5. That's my first intersection point. Now since I've solved for the x coordinate of the y equals 5, let's go and do it with negative 4. So if y equals negative 4, let's go and plug this into, I'm going to use this equation again. Negative 4 minus 5 equals negative x squared. Negative 9 equals negative x squared. I have a negative on both sides, so multiply both sides by a negative. I get 9 is equal to x squared. Square root both sides. I get x is equal to the square root of 9. So x equals plus or minus 3. Now that plus or minus is important. You have to have plus or minus because negative 3 times negative 3 is positive 9. So my second set of solutions, since I was using the x, or I keep saying x, y equals negative 4. The y coordinate is negative 4. My x solution is plus or minus 3. So my solution set, let me erase this. Plus or minus 3, negative 4. So this is my answer. That's my solution set. So how many points of intersections do I have? I have 0, 5. I have 3, negative 4. And I also have negative 3, negative 4. So I have 3 points of intersection. But this is your solution right here. Alright, let's go and look at how to solve a system of equations by using elimination. I prefer this method, but might not always be the easiest way to do it. So here we have 3x squared minus 6y squared is equal to 204. Now our second equation, 4x squared minus 2y squared equals 368. Now using elimination, basically what I want to do, I want to be able to get to a point, I'm just going to make this up, I want to get to a point where I have like 2x squared plus other stuff, and then a negative 2x squared plus whatever else, because when I add these two together, they equal 0, they disappear. And I'll be left with a single variable. Maybe I have y squared plus 4y squared. I can add those, and then solve for y, and then solve the rest of it. Now, the trick here is trying to make two of my variables have coefficients where one's positive and one's negative. So we're looking at these here. Do we see anything in common? We'll have a 3, I have a 4. The commonality there, the least common multiple, is 12. So I could do that, but even easier, I have a 6 and I have a 2. So if I multiply this 2 by 3, that would give me 6, but I need to make it a negative or a positive 6 because it is negative. This is negative, so I need to make this one a positive 6, and those will disappear. I'll be left with these. So what I can do is multiply all of this by a negative 3. Multiplying all of it by a negative 3 will take care of that issue. So this will give me, I'll jump down here with everything. So I have 3x squared minus 6y squared equals 204. I'm not going to mess with the top. The bottom one is going to give me negative 12x squared plus 6y squared equals a negative 1,104. Now when I add these together, negative 12 plus 3, that's going to give me negative 9x squared. These cancel out. So those cancel out, and I'm left with, I'm going to add those together, it will give me a negative 900. That gives me negative 900. Now it's just solving for x, so I divide both sides by negative 9. I get x squared is equal to 100. Take the square root of both sides. And get x is equal to plus or minus, don't forget your plus or minus, 10. So that's my solution for x. But again, I have to have an xy coordinate. So I have x, but I don't have y yet. So if x is equal to, let me rewrite this. So 3x squared minus 6y squared equals 204. And then I have 4x squared. This is my original setup. And I have x equals plus or minus 10. So since x is equal to plus or minus 10, I need to solve for my y coordinate now. So let's start with x equals 10. It doesn't matter which of these I plug it into. You just pick one. I'm going to go ahead and pick the top one. I'm going to use this. So when I plug this in, I get 3 times 10 squared minus 6y squared equals 204. 10 squared is 100. So that gives me 300 minus 6y squared equals 204. I subtract 300 from both sides. So negative 6y squared is equal to negative 300 plus 204 is negative 96. Divide both sides by negative 6. You get y squared is equal to 16. Square root of both sides, and get y equals plus or minus 4. So when x is equal to 10, my first solution is 10 comma plus or minus 4. So this is my first solution that I get. Don't forget the parentheses because it is a coordinate. Now let's do the same thing for when x is equal to negative 10. So when x equals negative 10, I can plug it into the same equation. I get negative 10 squared. Well, negative 10 squared is 100. So this whole thing just repeats. I get the same solution down here. So when x is equal to negative 10, I get negative 10 as my x coordinate, but I still get plus or minus 4 for the y coordinate. And that, so this will be your final answer. 10 comma plus or minus 4, negative 10 plus or minus 4. That's my answer. And the amount of solutions I have, if I were to write these out individually, here's my first one, second one, third one. I have a total of 4 solutions right here. But this is okay. You can write it like this. Now let's do one more. We'll be done. So this question here, I could use either substitution or elimination. Both would give me the answer. But since I notice I have, a little trick is just look, would it be easier to use substitution or elimination? Notice here, it's easier to use elimination because I have a 25x squared and a positive 25x squared. So all I have to do is just multiply one of these. Doesn't matter which. I'm going to multiply, let's do this bottom one by a negative 1. So this will give me, write the top again first. So rewrite the top. The bottom one's going to give me negative 25x squared plus 16y squared equals negative 400. I'm going to add these two together. Those cancel out. Those give me 25y squared is equal to, when I add these, get negative 175. Well, negative 175 divided by 25, get y squared is equal to negative 7. Now hopefully you see an issue here, because I have to take the square root of both sides, so I'll be taking the square root of negative 7. Now, we can do that, but it's going to be an imaginary number, and we're only going to be looking at our real solutions. We're not going to be dealing with imaginary numbers. So this, since I'm taking the square root of a negative number, there are no solutions. That is my answer. No solutions because I take the square root of a negative number. Now when you guys are doing these questions, you might come across something after you do substitution or elimination. Actually, maybe more of substitution than this would occur. Let's say you do your substitution, you end up something like this. Leading coefficient is not 1. So to solve this, I'd say the easiest way to do it, to solve for x here, would just be using the quadratic formula. Remember, this is A, B, C. So just use a quadratic formula if you do come across this type of situation. That will solve for your x parts or your y, depending on what you're solving for first. But you have to make sure to plug it back in. Make sure you plug it back in to solve for your x and y coordinates, however many you have. And then if you take the square root of a negative number, remember, that would be an imaginary number, so we're going to say that there are no solutions. Alright, that's it for today. Email me if you guys have any questions. Hopefully that was clear. Make sure you guys do the homework, and I'll let you know on a posting or maybe another YouTube video about what the plan is for next week. Alright, have a good day. See ya.